I'd like to start by going quickly over the hardware associated with the data acquisition unit. Essentially, the board is nothing more than a micro plus signal conditioning. We have the micro sitting over here. We have a switch mode power supply here from 24 volts to 5 volts and an isolated DC to DC switch mode power supply there. We have an RS-232 converter over here, and the rest of it is simply spike suppression and then conversion to allow, or at least conditioning to allow AC or DC coupling, and there's not much else. Connection to the unit is via screw terminals, which makes disconnection and reconnection quite easily through there. If I turn it over, you will notice again nothing more than the suppression and the AC-DC coupling, and a temperature sensor right over there next to the thermocouple input, which will measure, which is necessary for cold junction compensation. I did forget to mention that the thermocouple will connect over here, and of course that's the 9-way D sub for the RS-232 connection, which will connect to an RS-232 Bluetooth module, which would be outside the cabinet, and you see it here. What we are looking at here is a screen that has two analog channels on it, and it is synchronized, or rather triggering on channel B, which is the red channel, and showing channel A as the purple channel. The zero level of the signal is indicated by the arrows, as you see here and here, and as you saw there, it is possible to change the level simply by touching within that shoulder to move the signal up and down. You can change the horizontal gain, which incidentally is shown up over here, by using your fingers, by placing two fingers on the screen and moving them together or apart. Where you have a signal that stretches beyond the screen, in other words the expansion is greater than the screen, you can actually scroll through the screen this way or that way to move backwards and forwards across it. You can change the gains, again indicated up here and here, as to by using touch as well. Two fingers on the screen, let me move this down. Two fingers on the screen expands channel B, A, or contracts it, and you can move it up, and three fingers will expand channel B, as you see there. These of course can also be changed via other menus, and to bring up that menu you simply double tap on the screen anywhere. Before I discuss this menu, I should mention that there are two areas that settings get applied in the system. The first is on the screen, which is what you saw me do earlier, but there's also a possibility to change the settings on the data acquisition unit, and they tend to be exclusive. So the expansions you see on the screen have nothing to do with the actual expansion being recorded on the data acquisition unit, and vice versa, although they do translate when you get to see the actual numbers, the values up at the top. It does take both into account. The first menu you see here is setting up the different things on the screen. What you have here is controls that are similar to the touch controls that you saw earlier, and I can move the position up and down, and I can actually turn the channel on and off as well. In addition, there is a logic analyzer, as I mentioned earlier, 6 channels of it, and you can turn them on at 3 channels at a time. Turning on there, and you can see the transitions down at the bottom, and I can add the other 3 above that, and I can in fact spread them out a little bit so that you can see them expanded, to just make it easier to see, and of course I can turn them back off again just to continue with what we're doing. There is also the ability, as I mentioned to you earlier, of changing the settings on the data acquisition unit, and that I do by changing to this menu here. And you can see you can change the input multiplexer, the gain on that multiplexer, and the DC couple on both channels A and B, and you can change the channel you want from here, and then actually scan the same channel on both input channels, which is quite nice for checking the operation of the system. You can also change the sample rate that you see there. As I mentioned before, we are triggering on channel B at the moment, and I wanted to show you some of the controls at the bottom here. You can run and stop the signal, as you can with any scope. Run and stop. You can see over there it's a stop and it's not updating. I hit run there. I can erase, and of course because it's triggered it hits immediately. If I run and stop and then erase, of course it clears and waits for the thing, and now I can do even a single scan, same as any scope, so we're fine. Now we're back to run. The trigger, you can see I can show the trigger here, and it shows up as a yellow trace across there for a few seconds to show where you're triggering. And you can change the trigger level with these 4 buttons here. The 10 times is just a high-speed method of moving the level up and down, as opposed to the single, which is a much finer control. You can also set the trigger or remove the trigger by tapping on it, and it brings up this menu. You can set the trigger setting to none, to channel A or B, or to the digital pattern on the logic inputs. It has an additional feature that you can use the logic inputs to condition the input channel A or B, and so that when the condition is true, it then enables you to the trigger on channel A, and only does it when that condition is true. And of course you can change the sense of the trigger to positive going or negative going, and in the case where it's a digital trigger, it is whether it's true or false. You can set the pattern that you want to trigger on with this menu, and you can set the input pattern to 0 or 1 or a don't care. And there you have a basic overview of a Bluetooth connected oscilloscope.